Hello everybody and a warm welcome. My name is Peter Kjær. I'm the product manager for the portable vibration measurements instrument product line of B&K Vibro. The following training video introduces some functionalities of our Series 80 portable instruments, comprising the VIBROTEST 80 and the VIBROPORT 80. Both vibration measurement instruments are mainly used in offline monitoring applications, such as vibration analysis, field balancing, and data collection. The vibration measurements are part of a predictive maintenance strategy for rotating machinery. Ultimately, they help provide uptime, maximize the machine life cycle, and last but not least, save maintenance costs. Enjoy the following video.
Hello everybody. Let me welcome you to this training session here at B&K Vibro, Brüel and Kjær Vibro in Darmstadt. My name is Michael and I want to introduce to you the overall module of the VIBROTEST 80 and the VIBROPORT 80. As you perhaps already know, the functionality and the measuring modules, the available measuring modules for both devices are exactly the same. So everything I will tell you today, and hopefully everything you will learn today, is permanent for both devices. Let's have a short look at the agenda. First of all, we want to learn something about the importance of simple measurements. Then we will learn about the benefit of being able to do two measurements simultaneously. Then I will show you how easy it is to operate the instruments. And last but not least, I want to do a live demonstration because nothing's better for understanding than doing it live. When I make presentations or trainings with my customers, I always start with a statement saying that vibration measurement is divided in 3 steps. And the first step is always to evaluate the condition of the whole machine with a simple measurement. A simple measurement is like measuring fever at yourself. When you awake in the morning and you're not feeling good, you say, ooh, something's wrong with me. You take a thermometer, you put it in your mouth or in your ear, and you measure your temperature. You have a look at it and you say, okay, I have 38.5 degrees Celsius, I'm ill. Then your wife comes in and says, hey, what's going wrong with you? And you say, I don't know, I only know I'm ill. And that's a simple measurement. And it's equal in the industry, where we have also simple measurements. We call them overalls. An overall is a very quick and easy measurement to evaluate the condition of the machine. Overalls are established in all kinds of industry around the world, and they are part of national and international standards. And for that, these overalls are an accepted way to evaluate the health of our machine. Here in this picture, you can see an example for an industrial machine. This is a vertical pump set. You can see we have electrical motors over there. Then we have a shaft with a coupling. And we have the vertical pumps. And all this is fixed on a foundation and combined with pipework. You can here see a measurement that we've taken at this machine, and we can see the value, the overall we have taken was 1.99 millimeters per second, the RMS value of this overall. A value of 1.99 millimeters per second is a very good value for this machine. However, this machine could have several different failures, like an unbalance of the electrical motor. We could have an unbalance of the pump due to several reasons, like thermal deformation or material caking or something like that. We could have a misalignment between motor and the pump. We could have electrical problems. And all these problems lead to vibrations. And our overall now combines all the vibrations within a predefined frequency range, and it combines it, whether they are high or they are low, to one value. And this value evaluates or gives us the possibility to evaluate the condition of the machine. Now, a very good question at this point could be to ask, who defines or who tells me what is a good value or what is a bad value? And if you don't get any limit values, for example, from a manufacturer of a machine, or if you don't have any own experience in this case, then it is the best way to orient at national or international standards, like the ISO 10816. The ISO 10816 applies for the measurement type absolute bearing vibration and is the relevant measurement type for industrial machines with rolling element bearings. We have the ISO 7919, which applies for relative shaft bearings, and that's the relevant measuring type for industrial machines with journal bearings. Within this ISO 10816, we had so-called assessment zones. We had 4 assessment zones from A to D, and assessment zone A means vibrations for newly installed machines. Assessment zone B means vibrations for machines that can operate without a limit. The zone C means vibrations for machines who can operate in a period of time. When you erase zone C, then you already had a defect at your machine, but it's not so dangerous that you have to stop it immediately. You can operate your machine for a limited period of time. But zone D is for machines, then your vibrations are very dangerous and you had to stop your machine and do some maintenance. We can here see an extract of the ISO 10816, and we see the values recommended from the ISO 10816, and you can see that everything that's below 1.5 millimeters per second is in zone A. Everything that's below 2.8 millimeters per second is in zone B, and so on. And when we compare it to our value, 1.9 millimeters per second, then we can see that according to the ISO 10816, the machine we have measured is in very good condition. However, we had to take care of something. As I told you before, the overall combines all vibration elements of our machine, including a defect bearing. But the problem is that the amplitudes that a defective bearing sends out are very, very low, and they have no influence on our overall. So if we just measure our standard overall according to ISO 10816, then it could be that we believe that our machine is in good condition while our bearing is close to death or close to damage. So we had to find another way to have a closer look at the condition of our bearing itself. We will do a second measurement at the same time with the same sensor, and that's the benefit we get from the VIBROTEST 80 or the VIBROPORT 80, that we are able to do two measurements simultaneously. We will choose path A of the instrument and measure our standard overall according to the ISO 10816, and on path B we choose another overall, a special overall, just to monitor the condition of our rolling element bearing. Here we have the display of our instrument, and you can see that we have on the left side we have the overall for the machine, and on the right side we have a special overall just for our rolling element bearing. Here in this slide we can see the difference between both measurements. On the left side we can see the measurement according to ISO 10816, and the ISO 10816 recommends to measure the vibration velocity, the RMS value of the vibration velocity. And the RMS value of the vibration velocity represents the power of the vibration, with which power is the machine vibrating. And we are measuring it in a predefined frequency range from 10 Hz starting up to 1 kHz. And we have to beware of something. This is just a recommendation. 10 Hz means that this recommendation applies for machines with a speed greater than 600 cycles per minute. 600 cycles per minute correspond with 10 Hz. So if you have machines rotating slower than 600 cycles per minute, you had to adjust this frequency range. This is very important. On the right side, you can see a typical measurement for the evaluation of the condition of a bearing. This is called BCU. The value is the BCU value. It's called Bearing Condition Unit, and it's a special creation from Brüel & Kjær Vibro. And we are choosing a frequency band between 15 kHz and 45 kHz. And we use the resonance of our sensor to amplify the very low amplitudes of the defect rolling element bearing. And with this little trick, it's possible for us to have a close look on our bearing and can evaluate if it's in good or in bad condition. For a better understanding, I want you to listen to two audio files we create. The first one represents the overall measurement from 10 Hz to 1 kHz, and it contains all the dominant vibration components like the unbalance, the misalignment, the electrical fault, and all things like that. The second one should represent the high frequency measurement. Unfortunately, the human ear is not able to hear frequencies above 15 kHz, so we had to do a little signal manipulation to give you the chance to hear what's going on in the bearing. I find this very impressive. Okay, we will now come to point 3 of our agenda, and I will show you how easy it is to operate the instrument. Let's begin with pushing the start button of the instrument. And modern handheld devices like the VIBROPORT 80 and the VIBROTEST 80 are small little computers, so it always needs a little bit time for the instrument to boot up. According to our level concept, we are now on the top level of the VIBROTEST or VIBROPORT 80. You can see we have different kinds of icons here. We have blue icons, and the blue icons represent the measuring modules which are available for the instrument. And they are, in special case, more or less highlighted, and that depends on what measurement module you have bought. We have the red icons, and these icons are special icons to set up the device in an optimal way along to the needs of the user. We had the system setup where we configure general parameters like date and time and several other things. And we have the sensor setup, which contains a library of all possible sensors or transducers which you can use with the instrument. I will explain these two buttons a little bit later. Here we can see, as I told you before, the measurement modules, and it's possible to navigate with the navigation keys here to these different modules, and we can go into a module by pushing the so-called fire keys. We had 3 red fire keys on the instrument, and they have all the same function. It's just that it's for your convenience which fire key you will use, whether you are a left-hand worker or a right-hand worker. And now we can push the fire key, and then we go into a measuring module. And here we also have blue icons and red icons. And the blue icons represent predefined measurements. And you can choose one of these measurements, like a standard measurement, according to the ISO 10816, and you can rely on the parameters that are pre-configured. And if you do this, if you rely on them, you can push the start button and jump automatically into the measurement, and are now able to measure at your machine. But if you want to have a short look at the parameters behind that predefined measurement, you can push the fire key, and you can now have a look at the parameters and could probably change something if you wanted to. We go back. Even in this module we have 2 red buttons. We had a report button where stored measurements could be recalled, and we have the button New Measurement where we can create new measurement from the beginning. According to our agenda, point 4, we will now do a live demonstration of all the things that I've told you now theoretically. For that we will do a little break and do a little rearrangement for you. Yeah, hello again. We will now come to the live demonstration, and for that we will go back from our industrial machine, our vertical pump set, and turn to a small little demonstration motor with 2 flywheels. And I will show you the measurements, the operation of the device at this small little motor. And it's necessary to explain something to you. I need a third-party software so I can show the display, the screen of my instrument to you. As I told you, it's a third-party software. It's called Pocket Controller Professional, and you can download it from the internet under www.soti.net. Yeah, it doesn't cost as much. I think it's less than $50. And this software enables you to project an image of your device on a computer screen. And this could be very helpful, for example, for training sessions like we do here, or for the operation of the instrument via the internet. So it's possible that someone is sitting in an office, maybe in Germany, and the device is in China at a machine, and you can operate the device from your office in Germany via the internet. It's a very useful tool, I think. You connect your device with the computer, and then you can see the screen of our VIBROPORT 80 on your computer screen. Yeah, we want to talk about the overall module of this instrument, and we navigate with the navigation keys to our overall module, and we press the fire key. Then we enter this module. It also takes a little bit time. And here we can see that we have blue icons once again, and we have red icons. The red icons, we have, the first thing is the report. Within this icon, we have the stored data. So previously made measurements are stored here, and we can recall them and have a look at them. But the stored data is always related to the module we are in. So if you go into the report button in the overall modules, you can only recall overalls. So if you try to recall, for example, a spectrum, at this point it is not possible. The second red button is a new measurement. We will do a new measurement later, and I will show you all the parameters within this button. What's really helpful is that we have, as you can see here, predefined measurements. These are measurements, standard measurements within vibration measurement, and we have predefined the parameters within these measurements. It's for people who aren't so familiar with these measurements, or who didn't work every day with it. So they can come back to these predefined measurements, and they are sure that they do a meaningful measurement at this time. But before we do a measurement, we will go back. We'll go back to the first level and explain to you the system setup. The system setup is necessary at that point when you get a new device or new instrument. Then you have to do the configuration. It's similar to a computer. When you get a new computer, you have to configure it, things. And it's the same here. I will press the fire key and go into this module, and we'll have a look at all the different parameters. First of all, we had the memory. we had an internal memory with approximately, I think, 50 megabyte capacity. So I always recommend my customers only to use the card. So we use the card, or choose the card. The next parameter is timeout. Here we can predefine a period of time after which the instrument automatically shuts down. So if you're not working for 10 or 15 minutes and the instrument realizes it, then it shuts down to save battery. I, for myself, don't like the timeout function, so I always put it on off. Then we go to the units. In some countries we have the imperial units, for example in England or maybe in America, I'm not quite sure, but we're here in Germany, so we are using the metric system. We're coming to the channel setup. The channel setup has the possibility to choose copy to all. This is quite helpful when you are working with 2 or more sensors. Then you only have to configure one channel and the instrument copies it to all the other channels. So you don't have to configure each single sensor by yourself. But there are applications where it's perhaps useful to do an individual configuration. For example, when you use low-cost sensors with outlying sensitivities, then to make sure you do a meaningful measurement, it's absolutely important to configure each sensor by itself. Then you have a look at the configuration sheet and you get the sensitivity of each sensor, and then you are able to configure each sensor separately. But we put it on copy to all that makes life easier for us. Input range. We have the possibility of auto range, maximum, and sensor units. And most of the times we don't know anything about the range of the incoming signal. So it's always the best way to choose automatically. Then you're on the safe side. There could be applications like spindles, tool spindles, where you have very, very low amplitudes, and the amplitudes are in a very small range. Then you could use the sensor units and give them a fixed range by yourself. But most of the time we use auto range. Then we're coming to the speed measurement. It's possible to enable a speed measurement or disable it. For most of the measurement modules like the overall or the spectrum, it's not necessary to measure a speed. The problem is, if you enable the speed measurement, then the device wants to have a speed. You have to fix a speed sensor, you have to fix a reflection mark. Otherwise, if the instrument don't get a speed signal, it will do nothing. So beware this in mind. If you are on site doing a measurement and you only see stars on your display, then it could be that you enable the speed measurement but don't give him a speed signal. So for our application today, we don't need a speed measurement, and for that we set it inactive. Filter entry, we can choose between stepwise and free. Here I recommend always to use the stepwise. That means that in measuring modules, for example, where you can choose the frequency range, you get most popular frequency bands, and you can choose from these bands. Free would mean that you can define your own frequency range by hand, saying, okay, I want to measure from 7 Hertz to 389 Hertz. But in 15 years in my vibration life here at Brüel & Kjær Vibro, I've never met someone doing that. So we leave it on stepwise. Trigger, we can choose between automatic and user. Also here we recommend to choose the automatic function, but it could be necessary to choose user. It's in that point where you have a very poor speed signal. So when you are, for example, balancing on site and your speed signal is not stable, or you don't get a speed signal, then choose user, and then it's possible for you in the relevant module to have a look at the incoming signal from the speed sensor. And then you can tailor your speed range, your input range, according to this incoming signal. And that could be very helpful in some cases. But we leave it on automatic. We had the module CCS. Some of our sensors need a power supply from the instrument. It's a constant current supply, and we can switch it on or off. I put it always on automatically, so every sensor gets the power as required. That makes life quite easy. We have a date. Coming to the date, we have different formats for the date. We're here in Germany and we appreciate to have day and month and year. So I choose day and month and year. We can choose a time zone. We can tell the device I'm now in America or in China or in Europe. We're in Germany today, so I choose as time zone Berlin. And then we go to date and time, and here is the mask where we can set the actual date and the time. We can change it, so when we store measurements, we always have the right time and the right date for that. Oops, that's wrong. We are having 10. Okay. Everything's all right. The next parameters, memory options, root font, and sensor change warning are related to root-based data collection, and they are not relevant in this training session, so we'll explain them in another training course. Last thing is language. We have the most popular languages around the world. We're here in Germany, so I have to talk in English. No, I would even prefer to talk in German, but then most of our customers couldn't understand me, so I try to go along with English. So, that's it for the system setup. We configure now all the parameters, and normally we don't have to go into the system setup every day. We do this once, and then it applies for all the modules we use. Okay, we press the apply button, and now everything is fixed. Let's have a short look at the sensor setup. As I already told you, we have a library of the sensors from Brüel & Kjær Vibro, which we can use with these VIBROPORT 80. I press the fire key and go into this module. And here you can see that we have the classic standard sensors from our program. As you perhaps already know, we have 3 types of measurements within vibration measurement. We have the vibration velocity, we have the vibration acceleration, and we have the displacement. And here we have the relevant sensors for these measurement types. AS always stands for acceleration sensors, VS stands for velocity, and the INX is a displacement sensor, so you can measure displacement when necessary. But it's very easy to add a new sensor if you would like to. It could be that you want to use a third-party sensor, or you are a service technician, you come to a machine where you find a fixed installed safety system. Fixed install safety systems sometimes have so-called buffered outputs, and at these buffered outputs you can tap the original sensor signal and can use it for your device. That's quite powerful. And for that you have to know the technical data of the sensor installed. And I will show you now how easy it is to add a new sensor. We can here press the Add button. We have here the function keys. We press the Add button, and now it gives us this mask. And we have here sensor. We can give the sensor a name. We can have a look at the sensor, how it's called. We can give him just a name as we want. And I will give it name, perhaps H. Okay. What kind of sensor family do we have? It is a vibration sensor. It's also possible to enter process sensors like temperature or pressure or something like that. But we have a vibration sensor. We have a look at the unit, the sensor unit. We go into, and we see that we have all the units known already. We have vibration, acceleration, we have velocity, and we have displacement, and so we have the relevant units for that. This is an acceleration sensor, so we choose the unit G. To enter the sensitivity, it's necessary to have a look at the data sheet. You can look at the data sheet with the technical information for the sensor, and there you can see the sensitivity of the sensor. And this is a sensor with a sensitivity of 99.8 millivolt per G. And we enter 99.8. And this is a special sensor who needs a power supply, a constant current power supply. So we had to put it on here. Okay, so everything's correct. We can press OK. And now this new sensor is part of our library, and we can use it for measurements in the future. We press exit, and we are now ready with that what my colleague once called the housekeeping of our device. Okay, let's come to the next point. We will now do a live demonstration of the module overalls. I navigate to the overall and press the fire key, and we want to do a completely new measurement from the start. So I choose the button New Measurement and press the fire key. Here are now all parameters we have to configure. First of all, we have the input channels. We can measure with 1, 2, 3, or 4 channels. It depends on the application. Most of the time it's enough to measure with 1 channel. Then we choose a sensor. I go, and here we can see all the sensors which are available in this instrument. We are measuring with a standard sensor, an AS63. So I select this one, an AS06X. We have a family of sensors with AS6. So we have the X there to put them all on the one, in one family. We will set the path A on active. That's necessary, otherwise we couldn't measure. The unit is millimeter per second. We are measuring the vibration velocity in accordance to the ISO 10816. And the detection is the RMS value. We have other detections like peak or peak to peak. This is a true peak or a true peak to peak. We could also detect the value with peak calculated. When choosing this, that means that we are measuring an RMS value and multiply them with √2. And when we choose peak to peak calculated, we are measuring an RMS value and multiply them with 2 times √2. So please bear in mind that there are a lot of different things that you could select, and it's always absolutely important to bear this in mind, because when you try to compare measurements to each other, if you have a colleague or a customer who says, I've done a measurement on site and I have this value, and you do a measurement on site and you have a different value, then please compare the measurements and have a look at all these parameters if they are completely the same. So if there's someone different here in this area, that could lead to problems and could lead to differences within the value. Another interesting detection is the crest factor. The crest factor is a very easy and simple measurement for the detection of bearing damages, early detection of bearing damages. You need one sensor, you choose crest factor. And what does the instrument do? The instrument measures the RMS value of the acceleration and the peak value of the acceleration, and it calculates the ratio of both. And you get a value, and if this value lies between 2.6 or 3.6, then you can be sure that your rolling element bearing is in very good condition. So it's a very easy measurement for you. Okay, we choose the RMS value, and now we're coming to the high pass. And now you can see what I've explained a little bit before. Here we can see the stepwise bands. We have several bands that we can choose, the most popular ones, and we choose 10 Hertz for the high pass. So everything that's below 10 Hertz, we didn't measure everything below 10 Hertz, and the low pass is at 1000 Hertz. So everything above 1000 Hertz we didn't measure. Okay, it's possible to choose the second path. We can put it on active, and now we had a second parameter list, like the parameter list for channel A, and we can here configure a second measurement. As I told you once before, with a normal standard overall, we can't see a damaged bearing, so we choose here as a unit our BCU value, so we can have a close look at our at our bearing and monitor with the second path the condition of it. Here's one other thing. We can activate a so-called record mode, where we can measure overalls versus time or versus speed. That could be very useful to have a look if the behavior of your machine changes within a defined speed range, or if the behavior of your machine changes due to other things like temperature, or I don't know, temperature is a good example. If you have a fan who is transporting high temperature air, then it could lead to thermal deformation on your blades or something like that, and that could change your behavior. And with this module, it's possible to say, okay, I want to measure my machine for an hour or 2 hours and have a look if the behavior change in this period of time. Or you say, okay, I have a machine which has a speed range from 500 cycles per minute up to 1,500 cycles per minute, and you want to have a look if there's something in this speed limit that have an influence perhaps on your behavior. Could possibly be that you have a resonance place in this speed range, and with this record mode it's possible to detect such effects. But we will leave it inactive and are now ready to do a measurement. First of all, let me start the engine. And now we can press either the start button or fire key. I will press the fire key and start the measurement. We have some LED lights here on the instrument showing what the instrument is doing, if everything's correct, if we perhaps have failure with a cable or something like that. But the green light shows us that everything's correct. Here we can see the relevant value, the overall, the vibration velocity in millimeters per second RMS. The value is 1.45 millimeters per second. That's a very good value. And our BCU value, looking in detail on our bearing, is 0.04, so it's quite nothing. If the values are varying, then that could be due to several aspects. For example, traffic in the near surrounding or a machine standing beside our machine. Then it's possible to press the average button, and then we get a stable value. So everything's correct, and we can press the stop button. We can store this measurement by pressing the store button, and now we can choose if we want to store it in the internal storage or on the card. We recommend always to store it on the card. And for that we have to press the store button once again, and the instrument gives us a suggestion for a report name and gives us the date and the time. But we will choose another name. In this case we say, okay, this is the driven end of the machine and it's the horizontal direction, so we called it DE and DE and HOR. So I know that we are measuring in the horizontal direction. You should use terms and names within your company that you are familiar to, and it's something like a language within your company. So everybody knows when you are talking of DE horizontal that he knows where you are. I have a customer who uses just numbers and saying, this is my first measuring point, this is the second one, the third, the fourth. But he's measuring always in the same way. So everybody knows when he's talking we have high vibrations on point 4, then everybody knows where is point number 4. Okay, we do another measurement and we move the sensor to the vertical direction. Now we have to go to the bottom last measurement. We don't have to do another configuration. We just choose last measurement, and for that we guarantee that the parameters we use for the next measurement are exactly the same as in the first one. So the measurements are comparable to each other. And now we have to press the start button. The values here are also very low. We press stop. Press stop, and now can store this. Once again, store. And now he gives us the possibility to choose last name, and when I press the button last name, he gives us the last name, and the last name was DE HOR, and now we are measuring in vertical direction, so we change this in DE could be useful to know the alphabet. And DE vertical, and so it's very easy for me to choose the second name. I press OK. Yeah, so now we have done 2 measurements at our measurement point. We stored the data for future analysis or demonstration or whatever. And now it's possible to send the data to a software we deliver with this instrument. It's called the REX software. For that we had to connect the instrument with our computer. We need a third-party program for that. It's a Windows program. It's called the Windows Mobile Device Center. You could download it for free from the internet. It's quite easy to do. And then the instrument communicates with the software, and it's very easy to download all the stored data from the instrument into the software. There you can have a look at it and embed them into a report for customers or something like that. It's also possible to unplug the storage card from the device and put it directly into the computer. That would be the second way to do this, but for myself, I always connect the device directly with the computer and connect it to the software. Okay, so that's it for today. Thank you very much.